All right, welcome to Module 4. So this week we'll be looking at production, which is probably something that you might be interested in, given this is a managerial economics class and we're trying to think about how to manage resources well to be productive as managers of a business. Of course, when it comes to business, there's always two sides of the equation, right? We have the cost side and we have the revenue side. And we don't need to go back to Business 101, but if profit is revenue minus cost, this section about production is really more about this cost side. So how do our inputs that we're using relate to the output that we're producing? And of course, since inputs and resources are costly, we have to buy them. There's this accounting cost, but there's also this underlying economic cost that drives this, which is the opportunity cost of using a certain resource for one thing versus another. And so that's going to be one important part of the equation. We're going to see in the next module that understanding our revenue is going to require understanding what's going on the demand side for our product. And that's going to be related to market structure. So the demand curve that an individual firm faces depends on not only demand for that product, but demand for this specific company's product, which has to do with the market structure. So if you're a monopolist, the market demand is the demand you're facing. If you are in a competitive industry, then you're more or less forced to just price things at whatever the market price is. Of course, in the real world, we're probably most often somewhere in between those two dramatic cases. But I'll have to say, understanding the cost side is going to be really important for trying to understand how to maximize profit with our resources in a business. So the goal this week is to understand and explain the fundamental concepts of production and cost analysis, both in the short run and in the long run. So we want to understand the product, or the production function. So the production function is going to be thinking about how inputs relate to our output, or our quantity produced, and then our cost is going to have to do with exactly how much it costs to produce a certain quantity. So for a certain quantity, what is the cost? And so we can look at both on the product side and the cost side, what's the total cost, what's the total product, what's our average cost, our average product. So we have our average product, say per unit of labor or per unit of capital. We have our average cost, which is our cost per unit of output. Then we could look at our marginal products and our marginal costs as well, which tells us if we had one extra unit of labor, how much extra output could we get? If we had one extra unit produced, how much extra would that cost us to produce? Then we want to think about our optimization theory. This is going to be in some ways pretty similar to optimal consumption, but we're going to try to determine the optimal combination of inputs using isoquants and isocost curves, which I'll briefly explain here, and you'll see in the textbook. And so we want to think about the cost versus the benefit of using more of one input versus another input, and use that to consider how we can find the optimal combination of inputs to get to a certain quantity. And then we can look at the expansion path, which basically tells us for all the different quantities we could produce more or less. What are the optimal combinations of inputs for all these different quantities that we could produce? Then we want to look at factors influencing our long-run costs. Two really important things to consider are economies of scale and economies of scope. And so that'll be kind of influencing our long-run costs. And then lastly, we've done a little bit of statistical work so far, but we want to think about bringing this to the data, bringing this to the real world, and estimating short-run production and cost functions using linear regression. Okay, so Thursday night, the first thing to note is that we have test 1 on Canvas, which is multiple choice. It's open book and open notes, but no other sources of help are permitted. Before you take that test, feel free to reach out for help if you have any questions as you're looking through the homework and past things. There is a time limit on this Canvas test, but you're able to kind of take that whenever you want to before Thursday night. Then moving into this module, we'll be focusing on production. And to start us off, I want to look at this article on how firms adjust prices in a high inflation environment, which could be something kind of worth thinking about, especially as we reflect on the past few years when, especially say like 2 years ago, 3 years ago, we had pretty high inflation and prices were going up. All right, and then we have 3 chapters that we're looking at this week, and so these assignments will be due Monday night. And so we'll talk a little bit about each of these 3 chapters here, but I'll try to keep it a little bit brief so you can kind of move on and look at things in the book. If you have any questions or things are kind of confusing, sometimes it's best to look at these homework problems first and then kind of search the textbook to understand the necessary concepts. However works best for you is a great approach. But if you have questions as you're going through things, don't hesitate to reach out via email, or you can find a time to meet there on the link on Canvas. Okay, so Chapter 8 is about production and cost in the short run. So first we'll start with some general concepts, then look at production in the short run. That's this mapping from inputs, so we have capital and labor, to our output, our quantity. Short run cost of production is thinking about, given that relationship, for different quantities, what is our cost? And then we can kind of think about some of the various relations between short run costs and production. So in terms of general concepts here, we're thinking about a production function. And a production function is just how inputs relate to outputs. So for example, one that we might look at here is our quantity of output as a function of both the amount of labor we use and the amount of capital we use. So we could write this out in a number of forms. We could have a Cobb-Douglas production function. You can have a production process that's more capital intensive or more labor intensive, but this is sort of just a general format. We're thinking about how our inputs relate to the output that we're getting for our product. For technical efficiency, that's the question of, for a given combination of labor and capital, how do we get the most output? And we're sort of assuming this when we think about a production function. So engineers, business people, you can figure out how to turn a certain amount of workers and a certain amount of capital into as much output as possible. That's sort of the technical efficiency for a given combination of inputs. How do you get the most output? The economic efficiency question is, how do you do this in the most efficient way? So if you have a certain amount of output, how do we minimize our cost? So that's the idea of economic efficiency. So what's our optimal combination of capital and labor to get to the lowest cost of producing a given quantity? That's more what we're thinking about on the economic side. Okay, and then one important thing to note in terms of general concepts is the idea of short run, which is going to be where we start in this first chapter, in Chapter 8. And short run is really just going to mean however long the time period is when one or more inputs are fixed. So this is our time period when one or more inputs are fixed. There could be various reasons for an input being fixed. So if we think about this production function, we might often look at like labor and capital here. So we have labor and capital. The easiest way that we might look at this as one example of thinking about fixed versus variable inputs would be to think about capital being fixed in the short run and labor being the one that we can vary, the flexible input that we can decide to use more or less of. And so why would capital be fixed for at least some period of time, which we'll call the short run? Well, it could be because there's an indivisible or lumpy amount of capital that we're buying. So for example, if you buy a tractor, you can't just choose to buy 20% of a tractor and get 20% more output. You either have to buy a whole nother tractor or just not buy a whole nother tractor. Or same if you're talking about building a new manufacturing plant or whatever that is, that's that big amount of capital that you can't just divide up and use a smaller amount of necessarily very easily. That's one reason. The other reason would be that there's adjustment costs, and maybe this is more what we're thinking about as we're thinking about this time period when this is fixed. It might take a while to adjust how much capital you have. You might not be able to just get a whole bunch of new equipment or a new factory built tomorrow. It takes time to make that adjustment. And if you have too much capital, it's going to take time for you to kind of unwind that investment and sell it off. So that's kind of the short run that we're looking at. So as we look at production in the short run, we want to think about our output as a function of labor and capital. And as we're looking at the short run, we're thinking about one of these being fixed. So if capital is fixed, then we can write this sort of as so, where we're thinking about varying labor, but a fixed amount of capital. And so really, we're just varying the amount of labor we use to get a different amount of output. Okay, so that's sort of the basic idea. We could look at our total product, which is Q. We could look at our average product of a unit of labor, which is going to be our output divided by the number of units of labor we use. And then our marginal product is going to be, for an extra unit of labor, how much more output do we get? So if we hire one more worker, how much does that increase our output? So we have our change in quantity over our change in labor. And of course, our production, this relationship between labor and quantity, is of course going to shape our relationship between how much output we're producing and how much it costs to produce that amount of output. And so that's sort of our next step. So with our short run costs, we could think about our total cost as equal to our total fixed cost plus our total variable cost. So if we go back to the simple labor and capital example, the total fixed cost would be our cost of capital in the short run, and our total variable cost would be our cost of labor, which we can vary depending on how many workers we hire. And so as we look at this relationship between output and what it costs, we can think about our total cost. And just like we did with our product, we could think about our average cost, which is going to be, if we call our total cost TC, this would be our total cost divided by the quantity. Our marginal cost is going to be that rate of change. So as we increase our output by 1 unit, our change in quantity, how much is that going to change our total cost? So this is our change in total cost divided by our change in quantity. All right, and then we can look at some relations between short-run costs and production. So we can see some of the ways these different curves are related. So we have these relations between labor and output, these relations between output and what it costs, and then we can look at how all these things are kind of related on this last section here. All right, chapter 9, we're going to look at the long run. And so in the long run, we're going to assume that inputs are variable. You can change how much capital you want in the long run. You can change how much labor you want in the long run. And so now, instead of having capital be fixed, you can pick how much labor, how much capital you want to use. And so there's sort of two parts of the business owner's problem here, right? The first question is, for a given quantity, what's the optimal combination of labor and capital to get to this quantity? How can we produce this quantity at a minimum cost? And the second question is, how much quantity should we produce? And it turns out that the second question, how much quantity should we produce, is going to depend on the revenue side as well, which will kind of delay that question until the next module, once we look at market structure and how that influences the demand for your product as a business owner. But for now, we want to look at really this first basic question, which is how do we produce a certain quantity at a minimum cost by getting the optimal amount of labor versus capital? And then we can think about the expansion path, which is going to be looking at if we wanted to increase the quantity, what combinations of labor and capital would we want to use to get the optimal amount of inputs for each potential quantity we could produce. Okay, so let's focus first on these three. So we're going to look at isoquants, isocost curves, and the optimal combination of inputs. It turns out that this is going to be kind of similar to optimal consumption choice in the last module. And so for our production isoquants, we're looking at combinations of capital and labor that map to the same quantity, iso same quantity. So what combinations of capital and labor get us to the same quantity? And we're going to expect that this is probably going to be curved inward due to diminishing marginal product of each one. And so the more we have of one, whether it's capital or labor, the less productive it is to use more and more of that input. And so we have, for one isoquant might get us to this quantity. If we use more of both, we can get to a higher quantity. Those are our isoquants. And this is going to be dependent on our production function. And we're going to look at the marginal rate of technical substitution, which is just this slope. It's the negative of this slope here, which is basically saying if we got rid of one worker, how much capital would we need to still produce the same amount of output? That's going to be the slope along this isoquant. And so if we already have a lot of capital here, we would need to get a lot more capital to replace a worker. If we don't have much capital and we already have a lot of labor, in that case, we would have a lower slope and we would not necessarily need much capital to replace one worker. So that's the isoquant. And then if we look at the isocost curves, this is going to be trying to hold our cost constant for a certain combination of capital and labor. So what are all the combinations of capital and labor that cost the same amount? And that's, of course, going to depend on the price of these things. We're going to say the price of capital is R. It's like our user cost of capital that we saw when we looked at investment earlier. The cost of labor is, of course, the wage, so we'll use a W there. And this should be more like a straight line. And so our isocost curves would look like this. The more we produce, the more we're going to need more of both of these things. But we have our options. We could use more capital or more labor. There's a linear relationship because we're assuming that there's a constant cost of capital and a cost of wage, which is the cost per worker. And so if you combine these two, that can help us get our optimal combination of inputs. And so what we're going to do is do something pretty similar to what we did with optimal consumption. We're going to combine these two, and we're trying to think about one of two things. We could think about maximizing our quantity for a given cost, or we could flip this problem around and think about minimizing our cost for a given quantity. Either one should get you the same thing, but we're going to have this sort of tangency condition that we saw with the optimal consumption before. And so if we kind of combine these two, imagine we have these iso cost curves. We're going to think about some kind of like point of tangency here, kind of related to our idea of marginal benefit and marginal cost, where we're going to want the slope of the isoquant to equal the slope of the isocost curve in order for us to be efficiently using our inputs. All right, and then in the long run, we want to think about optimization and cost, so we can look at things like our driving our long run costs, our economies of scale, our economies of scope, forces affecting this. Long run costs are going to be related to is it more efficient to produce at a larger scale, or is it more efficient to produce multiple goods within the same firm? It's going to be related to economies of scale and economies of scope. And then in terms of trying to think about this optimization, we want to look at this expansion path which is really just saying as we increase the quantity, what are our optimal combinations of capital and labor for each quantity as we increase that quantity. That tells us our expansion path. And we can look at with our long run costs, we want to consider that we can adjust things more in the long run. We can adjust our capital. So if you think about long run cost versus short run cost for a given quantity, the long run cost should always be less than or equal to the short run cost, because we have the same options that we had in the short run plus some additional options since we can adjust our capital stock. All right, and then lastly, we're going to look at cost estimation. And so we can specify a short run production function. We could use like a cubic function, for example, and do like a linear regression. So we're going to look at our function of labor and capital. And if we assume that capital is fixed in the short run, we can really just look at this as a function of labor. And so we can look at like a cubic function to estimate this and do a linear regression. There's some issues that we can look at, like forcing our intercept to be 0. If we assume that when labor is 0, our output is equal to 0. And so we can look at this relationship between labor and output. That's our production function. Or we can look at our relationship between our quantity and the cost. We can estimate that in similar ways. So hopefully that gives you a little bit of idea of what we're doing this week. Feel free to reach out with any questions, and we'll talk to you next time.